Welcome to the first video for the first problem for the second exam. In this problem, we're given a relatively simple beam with a loading, and we are told to find the shear and moment diagrams for it, and to determine the maximum and minimum shear and bending moment locations. So, in this video, we'll go through the shear equations, and we'll draw the shear diagram later. In this first problem, we need to solve for the shear and bending moment diagram for a beam somewhat like this. Yours might have varied a little bit from this. And we need to indicate our maximums and our minimums. So, we're given the reactions at B and D. So for our shear, we're going to have three functions representing it. We're going to have from A to B, there's going to be one shear function. Then from B to C, there will be another, and then a third that lasts from C to D. So from A to B, that's going to be pretty easy. From A to B, and let's have x1 start at A, and let's start another x at B, and a third and final x at C. I think that'll make it a lot easier. But from A to B, it's just going to be negative 9 kips will be our shear function. A little generous to even call it a function. And then from B to C, this will be a function of x2. x2 is going to start at B. So at B, that is where x2 will be 0. And that's going to end up being, well, let's call it this. Negative 9 kips plus 18.1 kips. Which is going to equal 9.1 kips. Now, from C to D, it is going to be a little bit more involved. We may wish to use the fact that the shear from C to D as a function of x3, as say x with 0 at C, is going to be equal to the integral of the distributed load function from C to D as a function of x2, 3. When we do that, that's going to tell us that it is going to be negative 2 kip per foot times x plus some constant of integration, C1, right? Kip per foot times x 3 plus some constant of integration, C1. In our case, C1 is going to be equal to the shear at C, because of course that does not change at C suddenly. That only happens to be of a point load, such as at A or B or D, but there's no point load at C, there's only a distributed load. So our shear function from C to D is going to be equal to, let's put C1 first, it's going to be equal to 9.1 kips minus 2 kip per foot times x 3. So now let's draw this out.